Okay, 16. You explain it. Carbon dioxide and energy production, least squares regression line is y hat is 0.7676x minus 52.6841 relates carbon dioxide emission in hundred thousands of tons y. So this is CO2 emissions and energy produced megawatts x, that's energy produced in megawatts for all countries in the world in 2010. Interpret the slope. So A, 0.7676 over 1. Okay, so as we said before, this is your slope is rise over run, or change of y over change of x. So we got to get our units. This is carbon dioxide over energy. So the question is, what in the world are our units? So we've got to look at hundred thousands of tons or hundred thousands of tons over hundred thousands of megawatts. Okay, so for each increase of 100,000 megawatts of energy produced, that corresponds with an increase of 0.7676 hundred thousands of tons of carbon dioxide. Okay, on average. Okay, for each increase of 100,000 megawatts of energy. That's a lot of energy. There is associated an increase of 0.7676 100,000 tons of carbon dioxide. It's weird to think tons of gas, but when you compress it enough, it becomes a solid. For each increase of 100,000 megawatts of energy, there's associated an increase of 0.7676 100,000 tons of carbon dioxide. And again, that's on average. B, is the y-intercept reasonable? The answer is, I can say no. It is negative. Okay, negative 52, because we can't have a negative amount of emissions. And the reason that is because my data is all out here. And this model is good for my data, but when you get outside the data range, it's not valid anymore. And if you extend it, it goes down here to negative. So really what happens is it's linear here, but then it curves. In reality, it probably curves like something like that. But so we can't use our model for anywhere outside the data. That's called extrapolation. So it's only good for inside my data range. Let's see, so what would you expect the y-intercept of the model to equal? Well, if I don't produce, the y-intercept is when x is 0. And if I don't produce any energy, what would I expect my carbon dioxide emissions to equal? Well, if we don't produce any energy, I'd expect it to be really low, right? You know, not quite 0, because we're going to get carbon dioxide emissions from elsewhere, but it's not going to be very big. C, lastly, for 2010, lowest energy producing was Rwanda, which produced that guy. The highest was the United States, which produced that. Would it be reasonable to use this model to predict it for a country that produced that? No, because that's going to be way outside the range of our data. Again, that's called extrapolation. And that's bad. That's, again, why we'd have a 10-foot, 20-year-old. I know I use that example all the time for this, but it's the easiest one to see. You can only predict inside your data. In 2010, China produced 3260 and emitted that much 1,000 tons of carbon dioxide. What's the residual? Okay, so China produced 3120 100,000 tons of carbon dioxide. But what would we predict it to produce? 7676 times 3260 minus 52.6841. Is that right? Yeah. This is what we predict it to produce. 0.7676 times 2449, 2450 if we round it. 100,000 tons. So this is the predicted. This is the actual. So they're producing more than our model predicts. Okay, that's the residual. The residual is the difference from the y actual minus y predicted. So it's 2450 minus 3120. Oops, wrote it backwards. 3120 minus 2450. Okay. Which is what, 550, 650, 670, 100,000 tons of carbon dioxide. Okay, so that's this is what they burn over. They emit over what the model predicts. Okay, there we go.